All right, so for this question, we've got a cliff. Right, let's try again. We've got a cliff, which is 40 meters high, and this projection of something, a stone. There we go, of 20 meters per second. And this angle here is theta. So we're calling this 0, 0 here. So this is going to project up and then fall into the water there. All right, so what do we know? So then we would know at this point that y is equal to minus 40 at that point. All right, so let's look at the equations of motion. We've got x double dot being 0, so x dot, the horizontal velocity is 20 cos theta, because here we've got 90 degrees, so 20 cos theta. So x would be 20t cos theta. All right, what about y double dot? So we've got minus gravity, which they've told us is 10. So integrating, we've got negative 10t, but when t equals 0, we've got this 20 sine theta as our vertical velocity. And then we've got, if we integrate that again, 22 sine theta, and we're making 0, 0 at the point where the stone's thrown. All right, so we've got all that. So you can see that x of t is 20t cos theta and y of t, so y in terms of t is minus 5t squared plus 20t sine theta. So if the stone hits the lake at time t, so capital T, let's have a look at what we've got. So in terms of x, the x value, we at that time, so at t equals t, the x value will be 20t cos theta. So you can see cos theta will be x on 20t. And the y value, we know at that time, when the stone hits the lake, so here, that's at time t, we've got y equals negative 40. So let's put that in. Negative 40 equals minus 5t squared. Oops, that should be capital T sine theta. Now you can see with what we're trying to find, there is no angle in there. So what we can do is substitute. So if we know cos theta is x on 20t, we can substitute that in here for sine theta once we know what sine theta is. So what is sine theta? So remember, sine squared theta is 1 minus cos squared theta. So let's do that. So that's x squared on 400t. All right, so let's use that. Well, let's first make sine theta our subject for our y, and that'll make it easier. So first of all, what you might want to do is, so I was going to factorize, but you can see in the solution that they want here that there's 400s, there's 5s, and there's minus 40s here, so I'm not going to simplify anything, factorize by anything at the moment. All right, so making sine theta the subject at the moment, the first thing we would do is put the minus 5t squared over the other side. We've still got the minus 40, and then we would divide by the 20t. So you can see that sine squared theta would be, let's put this up a bit, so you'd get that 5t squared minus 40, so all that squared, and that would be on 400t squared. All right, so what did we say sine squared was? Let's sub that in here. So actually, let's make it, so x squared on 400t would equal 1 minus this stuff. So 1 minus all this stuff. 400t squared, is that right? So did I forget to just square that? I did. So that should be x squared. There we go. That's better. All right. So the other thing we can do is make this 1 here. Let's make it 400t squared on 400t squared. Then we can make this one fraction. So you can see we're going to get 400t squared, if I'm looking at the top, minus 5t minus 40 all squared. That's at the top. And on the bottom is 400t squared. But on the bottom of the left-hand side is also 400t squared. So let's just take the top of each, and we get x squared is 400t squared minus 5t squared minus 40 all squared, which is what we were looking for. There we go, that's what we're looking for. So remember, that's at time capital T. So if we take that and we, let's just clear a bit of space. So we, whoops, doesn't matter. So they've given us this equation here that we've just proven. So we'll go from there. So it says, hence find by differentiation the value of t that maximizes this x of t all squared. All right, so this x of t all squared, if we maximize that, we're differentiating. That's how we do it, yeah? So we're finding, whenever we do these maximum minimum problems, we're differentiating. So with respect to capital T, this becomes 800t minus, so the 2 will come down, so 5t squared minus 40 using the chain rule times 10t when I go inside there. So what have I got? I've got 800t minus, that'll be 20t, 5t squared minus 40. So they've both got 20t in them. So that'll be 40 minus 5t squared minus minus, so plus 40. So you can see there, that'll be 20t, that'll be 80 minus 5t squared. So actually I could put the 5 outside and make this, oh really I don't need to. I can just say, you can see that this is for this xt squared to be maximum, then I need xt squared dash to equal 0. So either t is going to equal 0, which we know it can't because that's where we start. So that is not where it falls into the sea or the pond or whatever it is. So the other thing we can have is that 80 is equal to 5t squared. So that means t squared is equal to 80 divided by 5, which is 16. So that means t must be 4 since we're saying since t is greater than 0. All right, so we know it's at time 4 seconds, I think. Find the value of find the value of t. All right, so t equals 4. That's our value. Let's have a look also at how far across that is, because we've got the y value, now we've got the time as well, so time equals 4. So let's see if we can find what x is as well. So if I go back to my x equation, or just the x squared equation at this time, so where's my, which is up here, there we go. So let's go back to that equation. Let me just get rid of that. All right, so going back to that equation, we've got x squared at this time when it falls is 400 t squared, so t is 4, so that's going to be 16, minus 5 t squared, so again 16, minus 40 all squared. So put that in the calculator, 4800. If we do the square root of 4800, because since x is positive to the right here, now 480, if I just go 4800 is 100 times 48. 48 is 16 times 3. So when I square root, I'm going to get a 10 and a 4, so it's going to be 40 root 3. I think it's meters across. So x is 40 root 3. So now I know everything at that point in time. So I've got to find the value of theta that maximizes the distance between the foot of the cliff and the point where the stone hits the lake. All right, so let's go back to where we had our cos theta, which of course I've rubbed out. So when we did our substitution, we took cos, remember we wrote down cos theta is x on 20t at that time. So let's have a look. When we know the x now, that's 40 root 3, and the time is 4, the capital T is 4, so that's 80. So you can see that's going to just be root 3 on 2. So what angle, cos of what angle gives you root 3 on 2? Well, that's 30 degrees. So theta would be 30 degrees.